let us solve some examples of increasing decreasing functions. Okay, let us take a few examples of it. So f(x) equal to x power x decreases in which interval? So here options given as 0e, 0 1 by e, 0 to 1 and 0 to infinity. Now we know if f dash x greater than or equal to 0, then f is increasing. If it is strictly greater than 0, then f is strictly increasing. Less than or equal to 0, then f is decreasing. Strictly less than 0, then f is strictly decreasing. So this is a concept. Now the derivative of x power x, we know it's a standard result, x power x into 1 plus log x, and here you are given x is greater than 0. Okay, now because x is greater than 0, or even in any way also, this x power x is always positive. Now if you want to have this function decreasing, so if f is decreasing, then f dash x should be less than or equal to 0. Therefore 1 plus log x should be less than or equal to 0. Okay, and so log x should be less than or equal to minus 1, and therefore x should be less than or equal to e power minus 1 to e, and because x is positive, our answer is (0 to 1 upon e). So B option is the answer. Here it is written decreasing, so we write less than or equal to, but we need to answer as per the given options. Next, f(x) equal to 2 times modulus x minus 2 plus 3 times modulus x minus 4 is blank. That means either decreasing, increasing, or kind of things in the interval 2 to 4. So options are decreasing, increasing, constant, or you can have say cannot be decided. So now see here, f(x) equal to 2 times modulus x minus 2 plus 3 times modulus x minus 4. Now here we are given x is in 2 to 4. So x greater than 2, and therefore modulus x minus 2 is x minus 2. X is less than 4, therefore modulus x minus 4, so then you are having x minus 4 negative, and so that is nothing but 4 minus x, or you can have minus of x minus 4, and therefore f(x) equal to 2 x minus 2 plus 3 4 minus x. So that is 2x minus 4 plus 12 minus 3x. So that is minus x plus 8, and therefore f dash x is minus 1 less than 0, and therefore f is decreasing in interval 2 to 4. So the answer is decreasing. Okay, let us take some more examples. Fx equal to x power 7 plus 5x power 3 plus 125 is blank. Options are decreasing in open interval 0 to infinity, then decreasing in minus infinity to 0, then increasing on R, and neither increasing nor decreasing. In R. So this is again easy example. So let us take f dash x. So that is 7 x power 6 plus 15 x square, and this is always greater than or equal to 0 for any x belongs to R, because power is 6, power is 2. So therefore f is increasing on R. So the C option is correct. Okay. Next, fx equal to 2x plus cot inverse x minus log of x plus root x square plus 1 is blank. Options are decreasing on minus infinity to 0, then decreasing on 0 to infinity, constant, increasing on R. So now let us see fx equal to 2x plus cot inverse x minus log of x plus root x square plus 1. Now we take the derivative. So f dash x is equal to 2, then derivative of cot inverse x is minus 1 over 1 plus x square, derivative of log is 1 over x plus root x square plus 1, and chain rule we apply. So derivative of x plus root x square plus 1, so it is 1 plus derivative of root is 1 upon 2 root x square plus 1, and again the derivative of x square plus 1 is 2x. So this 2 to cancel. Simplify 2 minus 1 over 1 plus x square minus 1 over x plus root x square plus 1. We take the LCM as root x square plus 1, and this is root x square plus 1 and plus x, and these two will be getting cancelled. So here remaining is 2 minus 1 over 1 plus x square minus 1 over root x square plus 1. Now let us simplify little. So let us take these two terms, suppose. Then this is a 2 plus 2x square minus 1 over 1 plus x square minus 1 over root 1 plus x square. This is nothing but 1 plus 2x square. Let us take LCM as 1 plus x square. So minus root 1 plus x square. So now we can easily see that 1 plus 2x square is always greater than or equal to root 1 plus x square. So this is always greater than or equal to 0 for any x belongs to R, and therefore f is increasing on R. So f is increasing on R. So option D is there. Okay, next let us take fx equal to x plus 2 e to the power minus x is increasing in blank. Options are minus infinity minus 1, minus 1 to minus infinity. This is not good option to be given. Sorry, minus infinity to minus 2, then this is 2 to infinity and a positive real number, that is 0 to infinity. Now f dash x, so we need to take the product rule, and so let us take the derivative of e power derivative of x plus 2, and that is 1, and let us take the derivative of e power minus x. So this is minus e power minus x. So e power minus x we can take outside. Here it is 1 minus x minus 2, and so this is nothing but e power minus x minus 1, or you can say minus 1 upon e power x plus 1. Now this part is always greater than 0. We want to be increasing, so the whole of f dash x, for f increasing, f dash x should be greater than or equal to 0. Now we are having already the negative sign here. So two negative sign, product of two negative makes us positive. So this should be negative. X plus 1 should be negative. So that we will have f dash x greater than or equal to 0, and therefore x should be less than minus 1. So x should belongs to in minus infinity to minus 1. So option A is the correct. Okay, let us take the next one. Fx is equal to tan inverse x minus x is blank. Options are increasing on R, then decreasing on R, then increasing on R plus, that means positive real number, and increasing on negative real number minus infinity to 0. So here let us take the derivative. So tan inverse derivative is 1 over 1 plus x square. This is minus 1. So this one is now LCM 1 plus x square. So this is 1 minus x square. So this is minus of x square over 1 plus x square. This part is always greater than or equal to 0. So due to negative sign, this is always less than or equal to 0, and therefore f is decreasing on R. So here the option B is there. Next, let us take fx is equal to tan x minus x, where x belongs to R minus 2k minus 1 pi by 2, k belongs to z, is blank. So options are increasing on its domain. So this is the domain. Then decreasing on its domain, then increasing on 0 to pi by 2, and decreasing on 0 to pi by 2. So now f dash x is derivative of tan x is sec square x minus 1, but this is standard result, and that is tan square x square. Square is there, so this is greater than or equal to 0 for all x belongs to its domain of the function. So the answer is it is increasing in its domain. Okay, let us take one more. If blank, then fx equal to x square minus kx plus 20 is strictly increasing on 0 to 3. So here for which value of k the function is strictly increasing. So k less than 0, 0 less than k less than 1, 1 less than k less than 2, and 2 less than k less than 3. Now see here, f dash x is 2x minus k. Now f is strictly increasing. So for f strictly increasing, f dash x greater than 0, and therefore 2x minus k should be greater than 0. Now see, x lying in 0 to 3. So 0 less than or equal to x less than or equal to 3. Therefore 0 less than or equal to 2x less than or equal to 6. And therefore minus k less than or equal to 2x minus k less than or equal to 6 minus k. That is our f dash x. Now see, f is strictly increasing. So f dash x should be strictly greater than 0. So f dash x should be strictly greater than 0. So minus k should be greater than 0, because this f dash x is greater than or equal to minus k from here. So that should be greater than 0, and therefore k should be less than 0. So answer is k less than 0. So option A is the answer. Next, let us take if f is decreasing in open and close interval a b, its minimum and maximum values are respectively blank. Options given as fa and fb. fb and fa. f of a plus b by 2 and fa. fb and f of a plus b by 2. So f is decreasing in open in close interval a b. So f is decreasing in close interval a b. Now the function is decreasing. So here a less than or equal to b and function is decreasing. So fa should be greater than or equal to fb. So that means the graph should be like this. Say suppose if we want to draw the graph, then the function should be decreasing. So it's like this. So this is fa and this is say fb. So maximum value you will get at fa. So maximum at fa and minimum at fb. So but here you take care, minimum first and maximum next. So minimum at fb and maximum at fa, so that care must be taken. So answer is this option B. So first ask minimum and then ask the maximum. So minimum is fb and maximum at fa. Okay, next let us see fx is equal to modulus of x minus 1 plus x minus 2 is increasing if options are x greater than 2, x less than 1, x less than 0, x less than minus 2. Now it asks increasing. So very quickly you can find that because the function you are having like in the interval, so if I take our x should be greater than 2 here, then fx is x minus 1 plus x minus 2. So this is 2x minus 3 and f dash x is 2 which is greater than 0. That means when x is greater than 2, then the function is increasing. So the answer is option A. Okay, take one more. If fx is equal to 1 by 5 power x, x belongs to R, then f is increasing, then decreasing, then constant, and none of these. So here f dash x, so the derivative of f dash x, if our fx is equal to a power x, so it is a power x log a. So 1 by 5 power x log 1 by 5, but log 1 by 5 can be written as log 1 minus log 5, so that is minus log 5. So this is minus log 5 1 by 5 power x, and therefore that is negative, and therefore f is decreasing. So answer is decreasing. So here in this you can have like this, if a lying in 0 to 1, then f decreasing, and if a is greater than 1, then f is increasing. Okay, next let us take if a less than 0 and f of t equal to e power at plus e power minus at. Suppose the set S is all t such that f of t is monotonically decreasing. Then, so basically we want to find out those t where f is decreasing. So options are that S is t such that t greater than 0, S is t such that t less than 0, S is those t such that t greater than 1, S is those t such that t less than 1. So now let us find f dash t from here. So f dash t equal to a e power at minus e power minus at. See, we can also write in this way: a over e power at e power 2at minus 1. This can be written as 1 upon e power at. Okay. Now the function should monotonically decreasing. Now take care, this a is given to be negative. A is negative. And if the function is decreasing, then this should be okay. E power at is always positive for any a, for any t. So this should be greater than 0, so that the whole of them should be less than 0 and the function is decreasing. So for f to be decreasing, f dash t less than 0, and this would definitely imply e power 2at minus 1 should be less than 0. Sorry, that should be greater than 0. So that the whole of function is less than 0 due to our a negative. Okay. Now therefore e power 2at greater than 1 can be written as e power 0, and therefore we can say 2at should be greater than 0, and because of a negative, again take care, a is negative and total is positive, so this t must be greater than less than 0, because if t is less than 0, a is less than 0, then 2at should be greater than 0, because both should be less than 0 to make the product is positive. So the answer is t should be less than 0. So option B is the answer. Okay, take one more. Fx is equal to 2x cube minus 9x square plus 12x plus 29 is monotonically decreasing then, so if f is monotonically decreasing, then options are x less than 2, x greater than 2, x greater than 3, 1 less than x less than 2. Now see f dash x. So f dash x is 6 x square minus 18x plus 12. Now we can factorize this. So f dash x is 0 will imply x square minus 3x plus 2 equal to 0, x minus 1, x minus 2 equal to 0. So this is equal to 6 x minus 1, x minus 2, and we all know to do this process 1 then 2. Now if our x is greater than 2, then we know that both are positive, f dash x is positive, so increasing. So here the signs are for f dash x in this way. What we want is monotonically decreasing, so answer is 1 to 2. So if x belongs to 1 to 2, then f dash x less than 0, f is decreasing, so answer is D option, 1 to 2. Okay, let us take one more. If f(x) is equal to x cube by 3 minus x square by 2 plus 1, then f is decreasing on blank. Options are minus infinity to 0, minus 1 to 0, 1 to infinity, and 0 to 1. So let us quickly find the derivative. So this is 3x square by 3 minus 2x by 2. So this is x square minus x into x minus 1. So exactly same way here, minus infinity, infinity, then 0, then 1. And if I take x to be greater than 1, this is positive here, f dash x sign, and like this. So therefore f is decreasing on 0 to 1. So answer is again option D. Next let us take f(x) is equal to x square plus kx plus 1 is increasing function on 1 to 2, then minimum value of k is blank. Options are minus 1, minus 2, 1, and 0. So here f(x) is x square plus kx plus 1, and therefore f dash x is 2x plus k. Now see, x lying in 1 to 2. So 1 less than equal to x less than equal to 2. Therefore 2x. So 2 less than or equal to 2x less than or equal to 4. And therefore 2 plus k less than or equal to 2x plus k less than or equal to 4 plus k. So this is our f dash x. Now what is question is increasing. So f dash x, f increasing will imply f dash x should be greater than or equal to 0, or you can say f dash x greater than or equal to 2 plus k, and that should be greater than or equal to 0. So therefore 2 plus k greater than or equal to 0, and therefore k should be greater than or equal to minus 2, and therefore minimum value of k is minus 2 as per the required condition. So answer is B option. Okay, next let us take if f(x) equal to sin x minus cosine x minus ax plus b is decreasing for all x in R, then blank. Options are a greater than or equal to root 2, a greater than or equal to 1, a less than root 2, a less than 1. Now we find the derivative here, and so derivative is f dash x is equal to, this is cosine x plus sin x minus a. Now see, we know that a cosine x plus b sin x, its range is minus root a square plus b square to root a square plus b square. So this cosine x plus sin x lying in minus root 2 root 2, because a is 1, b is also 1. Now so minus root 2 less than or equal to cosine x plus sin x less than or equal to root 2, and therefore minus root 2 minus a less than or equal to cosine x plus sin x minus a less than or equal to root 2 minus a. Now see, f should be decreasing, f decreasing will this is our f dash x. So this would imply f dash x should be less than or equal to 0 or less than 0, and that would imply our f dash x is less than or equal to root 2 minus a, and that should be less than or equal to 0. So root 2 minus a less than or equal to 0, and therefore root 2 less than or equal to a, or you can have a greater than or equal to root 2. So the option is a here, a greater than or equal to root 2. Thank you.